Okay, so today we're going to be doing 9-6 distance in the coordinate plane. I'm going to give you two examples right now of whenever you have a vertical line segment, which is on your y-axis, and a horizontal line segment, which is on your x-axis. It has to be perfectly vertical or perfectly horizontal for it to work this way. If it's not, then you're going to have to use the distance formula, which is derived from Pythagorean theorem. So let's go ahead and start. You read the length of a vertical line segment. Vertical, again, is your y-axis, so that this all is going to make sense, is the absolute value of the difference between the y-coordinates of its endpoints. So you're only looking at the y-coordinates. So the distance between x1, y1, and x1, y2 is y2 minus y1. Because there is no x values, that's why you're finding the distance between the y values. So let's go ahead and start. So y2 minus y1, the absolute value of y2 minus y1. Well, this is y1, this is y2. Your second one is always y2, your first one is always y1. So I'm going to plug it into my formula. I have 4, y2 goes first, see, minus y1, which is negative 2. You still have to bring that negative. 4 minus negative 2. When you have a minus and negative, you can flip, change. 4 plus 2, positive 6. So, the answer to the first one is positive 6. The distance between them is positive 6. And you can see that on a graph. So let's check our work. So let's go ahead and count. 1, 2, 3, 4, 5, 6. Awesome, I did it right. So the next one we're going to do is the length of a horizontal line segment. The length of a horizontal line segment, it has to be perfectly horizontal. You can always remember horizontal like a horizon, and the x-axis is always the horizon. So when you see a horizontal line, you know that it's perpendicular to the x-axis, so you can always remember you're going to be finding the distance between x2 minus x1. So I have x2, I didn't even give you the coordinates, but here they are. x2, this would be x2, minus x1, this would be x1. So negative 2, just kidding, positive 5, minus negative 3. Then I would do flip, change, minus the negative would be positive, the absolute value of positive 8, which is 8. Let's talk a little bit about what absolute value means, so you know. You should know, but I'm going to review you. So absolute value is the distance away from 0. So no matter if it's a negative 6, when you're finding the absolute value of negative 6 is still positive 6 away from 0. Distance is never negative. So 6 and 8, they're going to be positive no matter what. If it was negative, the absolute value of negative 8, it'd be 8. So let's go on to our next one. Okay, the distance formula is derived from the Pythagorean theorem. It can be used to find the distance d between any 2 points. Tomorrow when you come to class, I will prove that this is derived from Pythagorean theorem. But for now, all you need to know is that this is the formula we use to find the distance between any 2 points. If the line was a vertical or horizontal line, you can still use this and it would still work for consistency. But if you wanted it to be easier and you understood why, you can just use x1 minus x2 and y2 minus y1 whenever you're just finding a vertical or horizontal line. Then that's fine too. So let's go on. Find the distance in simplest radical form. So if you notice 1, negative 9, 3, 5, neither of those are the same values, as in the x values are not the same and the y values are not the same. If they were the same, that would indicate that you have a vertical or horizontal line. But since they're not the same, you're going to have to use the distance formula, which you should have written down in your notebook. The distance formula is x2 minus x1 squared plus y2 minus y1 squared. And it does matter order, so you need to know that whenever you're writing it down, your x values, x2 is right here, x1 is right here, y2 is your second y, and y1 is your first y. So let's go ahead and write it. Distance equals x squared, x2, which is 3, minus x1, which is 1, squared, plus y2, which is 5, minus negative 1. You have to put the negative 1 and then squared. So I'm going to go ahead and make this look a little prettier, and I'm going to do keep flip change so I know what I'm doing, and that's going to be 5 plus positive 1. So now I'm just going to simplify. So D equals 3 minus 1 is 2 squared, plus 5 plus 1 is 6 squared. So then I have D equals 4 plus 36, the square root of 4 plus 36, which equals the square root of 40. But I'm not done simplifying. How can I simplify the square root of 40? Well, I know it's not a perfect square, so I have to do the upside down cake. Divided by 2 is 5. Divided by 5 is 1. So I have a pair of 2, so that will be on my outside. Everything else that's not in pairs I have to multiply. 2 times 5 times 1. 2 times 5 times 1 is 10. And now that is simplified to the smallest term, so 2 and the square root of 10 is my answer. Looks like a lot of work, but for the most part all you do is plug and chug, and then you simplify. You are able to use calculators, so it should be easy for you, but I want to see your steps. I want to see you plugging in the numbers. I don't want to just see this. Hang on. I don't just want to see this equals this. I want to see all of the stuff that goes in between, and y'all know that, but you're still able to use a calculator. The next one. Find the distance in simplest radical form between each set of points. So, the distance formula is distance equals x2 minus x1 squared plus y2 minus y1 squared. I want you to pause the video and see if you can plug in the correct numbers, because once you've got that down, then you'll be good. Alright, so you should have plugged in distance equals x2 is negative 10 minus negative 3 squared plus y2, which is 1, minus y1, which is 8 squared. So distance equals the square root of negative 10 minus negative 3, you have to do keep flip change. Negative 10 plus positive 3, same signs add, different signs subtract. You take the sign of larger, 10 minus 3 is negative 7 squared, plus 1 minus 8 is negative 7 squared. So the distance equals negative 7 squared is negative 7 times negative 7, which is 49, plus negative 7 times negative 7, which is 49. So distance equals a way you can see this is the square root of 49 plus 49. This might confuse some of you, but if you go on, you're going to get the same answer as me if you go on a different way. So the square root of 49 plus 49 is the same thing as saying 49 times 2. Am I right? Well, I know the square root of 49. I know that that's a perfect square, and that means the square root of 49 times 49, 49 times 2 is 7 times 7 times 2, which means I can take out a 7, and I'd have 7 the square root of 2. Now, if you worked it the long way and didn't take that little shortcut, then you should have got, it's going to be kind of ugly because I'm going to write it sideways. The square root of 49 plus 49 is 98. And then you would have 98 divided by 2 is 49. Divided by 7 is 7. And then you would add 7, the square root of 2. And don't ever make your paper look like that. Paper you can move. Okay, so find the distance in simplest radical form between each set of points. I want you to do number 5. I want you to do number 5 and number 6. And tomorrow when you come into class, we're going to see how you did based off these notes. Okay.